Today we'll be looking at problem 41, first missing positive number. As usual, the 3 steps of solving any problem are 1. Understand it, 2. Visualize it, and 3. Implement. So, given an unsorted integer array nums, return the smallest missing positive integer. You must implement an algorithm that runs an O in time and uses constant extra space. So here we have an example, 1, 2, 0. The up it's 3 because 1 and 2 are there, and so the next number would be 3. Looking at the next example, we have 3, 4, negative 1, 1. The output is 2 because, well, we have 1, and we have 3 and 4, we don't have 2. And example 3, we see all these numbers, 7, 8, 9, 11, 12. The first positive integer is 1, and it's missing, so we return 1. So, with this kind of problem, you should definitely start thinking about which data patterns that would solve this problem. The one that I'm thinking about is cyclic sort, which is a linear runtime pattern where you sort of sort numbers. You don't necessarily sort them, but you place numbers at their corresponding index location, and you just keep iterating until you reach the end of the array. And for the most part, it will be sorted, and it will be sorted enough for our situation. So let me walk through how this cyclic sort algorithm works. So we have 1, 2, 0, and you ask yourself, is 1 at its correct index? So the most basic form of cyclic sort is 0 index, meaning that 0 goes at 0, 1 goes at 1, 2 goes at 2, and let's just do that for 1 second. So we look at 1. 1's supposed to be at index 1, and it's not there, so we go ahead and swap 1 and 2. Now we look at 2. Is it at correct location? No, it should be at 2. So we swap those guys. And now we see that 0 is at its correct location. 0 is at 0. 1 is at 1. 2 is at 2. So that is how you do a cyclic sort. The next question then, though, is looking at the question. So first missing positive number. Though the problem with doing 0 index is that 0 is not a positive number, so this isn't really helping us with sorting things in a contiguous fashion. What we actually want to do is one index. Just implement cyclic sort, but do one indexing, meaning that 1 will go actually at 0, 2 will actually go at 1, and 0 we can just ignore all these numbers. As long as we have 1s and 2s and contiguous from 1 to 1 forward, we should be able to create a correct rendition of correct rendition of all the positive numbers starting at 1, and then based on that info we should be able to then say which one is missing, because that's the end goal. We just want to know what's the missing positive integer. And so let's implement this exact same situation one more time of what that looks like. So we had 1, 2, 0, and is 1 at its correct location? It actually is, because 1 is at 0 now because we're 1 indexing, so technically we say 1 is at 1. Then we look at this guy. 2 is at, if you're 1 indexing, it's at 2. If you're 0 indexing, now it's at 1, which is correct. So 1 plus 1 is 2. In this case, 0 plus 1 is 1. And numbers that are less than 1 we can just ignore. So at this point, this has been cyclic sorted, and then you can just iterate over each number. So you say 1 is its correct location, 2 is there, and then here it should be a 3, and it's not, so we just say that the missing positive number is 3. Let's look at one more example. Example 2. 3 is supposed to be at index 2. It's not there, so let's move it there. And let's swap -1 and 3 is we can just ignore negative numbers, any number that's not positive. And let's look at 4. 4 is also not at its correct location, but it's also not it's also greater than the number of values in the array, so we just skip it. 3 is at its correct index, so 2 plus 1 is 3, and 1 is not at its correct index. It should go here to the first spot, so it'll look like 1, 4, 3, and -1. So we've one indexed using cyclic sort, and we started the first number, so we see 1 is there, but then we see that the next number is not 2, so we say that the missing positive number is 2, and that's the idea. So once more, it's cyclic sort using one indexing, and then you just go over the numbers in your array until you notice that you jumped or the number is just incorrect for what you're expecting. We expect 1, 2, 3, 4, in which case the missing positive number is 5. So what are the steps to implementing a cyclic sort? So we need a swapping function where you pass an array and you pass it which index numbers you want to swap. And now we do our cyclic sort, and we don't iterate. We use a while loop because over any given spot we may need to keep swapping until the correct number is in its place. And if you're unfamiliar with cyclic sort, I do recommend watching some of our other videos that talks about the fundamentals of cyclic sort. But so I will just skip that piece and just go ahead and implement our cyclic sort. So while it is less than nums.length. So here, remember how if the number is less than 1, because it's out of this range, we can just ignore it. Nums it is less than 1. We're only interested in things that are 1 or greater. Then we just keep going. Else if it's also out of range, we can just ignore it. Because, we may see like 1 and 10 or, 40. And where are we going to put that? Because, our array is size 4. We have nowhere to go with it. And it's not really going to help us with our determination of which is the next positive number. Greater equals to nums.length plus plus. And then so here we check all the negative numbers. Here we have all the numbers that are out of bounds. Now we want to ask if the number is not at its correct index spot. Nums it does not equal. So how do we get the one index position? We do nums it minus 1. So think about this example. So nums it would be, and it is 0, so this value is 1. And nums, so nums it, okay, here this is 1 again. So I'll just spell it out. Nums, this is 1, and then 1 minus 1 is 0. So here we see that this 1 is actually at its correct location. Because there you have it. Like these, in this case, it is one index. Using a one index concept, it is at its correct location. But if it's not, we want to do a swap. It and nums it minus 1. And in other cases, and the other cases would be where we have, for instance, repeating numbers. Like they don't have any constraints about uniqueness. So we may see some repetition with numbers. We just want to continue, and we can go ahead and just see what we're logging. So here we have 1, 4, 3, -1. This looks like what we had when we did this manually. So we can feel confident and keep moving. So we need to next find out what is the next largest number. And largest positive. We can just start with 0 because soon enough we'll see that 1 exists, in which case the next largest positive number will, it'll be switched to 1. So we just have to iterate. I equals 0, I is less than nums.length, I plus plus. So as per usual, we can ignore, just to keep looking back at what we did here. If nums I is less than 1, we can just ignore it. I'm not interested. And now we can start to compare against our largest number. If nums I minus largest positive is greater than 1, so this would be this example. So it'll be 4 minus 1, which is 3. Is 3 greater than 1? Then we found our rupture in our contiguous array, and we can return the largest positive number we found plus 1, because that's the next value up. And if now let's say that we had this guy. I'm gonna comment this out. Let's say you had this guy and you have 1. So let's say the first number is 1. We need to now update our largest positive. If nums I minus largest positive equals 1, we are good, and we can update our largest positive number. And the reason, once again, so similar to this case, that we don't want to just assume that if these two cases fail, we can just change the largest positive number, is that they don't have any constraints around uniqueness. So you may see the same numbers again, like you could see 1 and then 1. So 1 would would pass these cases, but it's not the next highest number. So we do want to do this check. And if that's all good, that this would be a case where you had say 1, 2, 3, and we don't have the end of this loop finished. We still have a largest positive number that was generated, and we just return that value plus 1. And let's submit that to see if we got it. So yeah, there you have it. Once again, cyclic sort using one indexing, and then simply keeping track of what the largest positive number you had. Thank you, and catch you later.